Have you ever wondered how electricity travels through wires to power your favorite gadgets? It's like a hidden highway system, bustling with tiny particles. Electricity is an essential part of our everyday lives. Today, we're going to explore the fascinating journey of electricity from generation to your devices. Let's plug in and get started. First, let's break down what electricity actually is. At its core, electricity is the flow of electrons. Electrons are minuscule particles found in atoms, which make up everything around us. Imagine a crowded street where electrons are like cars zooming along. But unlike cars, these electrons are moving incredibly fast. Sometimes, they move close to the speed of light. Now, how does this bustling flow begin? It all starts at a power plant. Most of our electricity today is produced by converting energy from natural resources. For instance, in a coal-fired power plant, coal is burned to heat water. This steam spins a turbine connected to a generator, which produces electricity. It's a bit like pedaling a bicycle. Your leg muscles provide the energy to keep the bike moving. Next, once generated, electricity enters the transmission lines. These lines are like the main highways we mentioned earlier. They transfer high-voltage electricity over long distances, sometimes hundreds of miles. High voltage is essential because it allows electricity to travel further without losing too much power. Think of it like turning on a water hose. If you increase the pressure, the water travels further. Electricity approaches our homes and reaches substations. Substations transform high-voltage electricity into lower voltage. This process ensures safe use of electricity in homes. It's similar to reducing water pressure before it reaches your faucet. Transformers within substations step down the voltage. This makes electricity safe for everyday use. Electricity travels to our houses through a series of distribution lines. Imagine a maze of small roads leading directly to each home. It's similar to a delivery truck navigating through streets. The electricity is now ready to power your lights and fridge. Don't forget about that ever-important coffee maker. Electricity flows through wires in two main forms: direct current, DC, and alternating current, AC. In DC, electrons flow in one direction, similar to a one-way street. Batteries typically use DC to power devices like flashlights and remote controls. In contrast, AC allows electrons to shift back and forth, resembling a two-way street. AC is the electricity type used in most homes, as it is more efficient for long distances. Now, let's talk about how electricity is controlled in our homes. You may have noticed that when you flip a switch, the lights turn on instantly. This is due to a network of circuits. A circuit is a closed loop that allows electricity to flow. Think of it like a racetrack. The electricity travels around and around. It lights up bulbs, powers appliances, and keeps your devices running. Next, let's touch on something fascinating: the idea of resistance. Resistance is like friction in a race. It slows down the flow of electrons. Various materials conduct electricity better than others. For example, copper is an excellent conductor. This is why it's commonly used in electrical wiring. It's like choosing a smooth road over a bumpy one for a faster trip. What happens when there's too much electricity flowing through a circuit? Safety mechanisms come into play, like circuit breakers and fuses. These devices act like traffic signals, preventing overloads that could cause damage or fires. When they detect too much current, they cut off the flow. This ensures safety in our homes. Electricity travels through a complex journey. It powers everything from power plants to gadgets. Understanding this flow enhances our appreciation. This invisible power lights up our lives. If you found this exploration of electricity as fascinating as we do, don't forget to hit that like button, subscribe for more electrifying content, and share your thoughts in the comments. What other science topics would you love to learn about? Until next time, stay curious and keep exploring.